Okay, so here is an example of the kind of question that we can solve using right triangle. Well, one of the questions we can solve using right triangle trigonometry. Suppose we have this kind of triangle here. We have a right triangle where the sides length are 3 and 4. We don't know what the hypotenuse is, as we can see, and we do know that this angle down here is theta. What we're going to do is we're going to find the values of all the trig functions. We're not going to try and figure out what theta is, okay? Can we figure out what theta is off the top of my head? Honestly, I don't know, but for now it doesn't matter. So let me just redraw the triangle. We have a lot of room here. So again, this was this here. Here's theta. This was 3. This was 4. Let me just double. Yep, I'm right. Yeah, oh no, I got it backwards. Excuse me. It's easy to fix. Here's 3. Here's 4. That's right. Good, good. Okay, so again, we have to get the length of the hypotenuse. So just to make it a little bit easier, well, let me call this, I guess, actually hypotenuse. Let me do that. Now, since this is theta, we actually have then the adjacent side, the length of it is 4, and the opposite side we have is 3. So we're going to get all the trig functions now, okay? So first we have to figure out what the hypotenuse is. How do we do that? We're going to use Pythagorean's theorem. Namely, by Pythagorean's theorem, 3 squared plus 4 squared is equal to the length of the hypotenuse squared. So, let me just see if I can make that a little bit nicer. Wait, made it worse. There we go. Okay, so we have 9 plus 16 is equal to the hypotenuse squared. So 25 is equal to the hypotenuse squared. Okay, so what does that tell us? That tells us the hypotenuse then is going to be the square root of 25, which we know is 5. So now that we have our 3 side lengths, we can easily obtain the other trig functions, right? Remember, we know that sine of theta, right, is opposite over hypotenuse. So we have here 3 over 5. So let me just separate. So that's what we have here. Now let's get the other ones. Cosine of theta, well, remember, that's adjacent over hypotenuse. Okay, so let's substitute in, so to say. The adjacent side we know is 4. Hypotenuse is 5. Now, tangent of theta, right, that's opposite over adjacent, which is 3 over 4. Okay, right? We have the opposite side is 3. We have the adjacent side is 4. Hypotenuse, as we just calculated, is 5. So we have sine, cosine, tangent. Let's get the other ones. Cosecant of theta. This is not the definition, but remember, one of the identities was it's 1 over sine of theta. And when you have 1 over a fraction, that means you take its inverse. In other words, you flip it. So we actually have here 1 over sine, which is 1 over 3 over 5, but that's the same thing as 5 over 3. So now for secant of theta, that is 1 over cosine of theta. So essentially we're going to do the same thing as we did with cosecant, except now we have 4 over 5. So we have 1 over 4 over 5, which is the same as 5 over 4. And finally, cotangent of theta, that's 1 over tangent. See if we can draw that. Move it up a little. So we have 1 over 3 over 4. But again, 1 over something means you flip it. So we have 4 over 3. So we have our answers here. We have sine, cosine, tangent. we have, we have sine, cosine, tangent. And we have cosecant, secant, and cotangent. And again, notice that we didn't figure out what theta is. But what's nice is we didn't have to. We didn't have to try and figure out what theta is. We were able to figure out what sine, cosine, and tangent are, and so on. Okay, so this is another kind of problem. This one's a little bit different. Notice that we don't have the triangle. What we do know is that cosine of theta is 1 over 3. Now, we want to figure out all the other trig functions without trying to figure out what theta is. Okay, well, remember, cosine of theta is here it's 1 over 3, but by definition, it's the adjacent over hypotenuse. So here, what we have is 1 over 3 is equal to the adjacent divided by the hypotenuse. Now, to figure out what the other trig functions are, what I'm going to do here is I'm going to set the adjacent side to be 1. And I'm going to set the hypotenuse to be 3. In other words, we want a right triangle, okay? We want a right triangle like so, where cosine of theta equals 1 over 3. So we want a right triangle now, okay? Where cosine of theta equals 1 over 3. So here's a right triangle like that. I want to set the adjacent side to be 1. The hypotenuse, I want it to be 3. The opposite side, we don't know. So here is a right triangle where cosine of theta is 1 over 3. Okay, but how do we get the other trig functions? Well, we need the opposite side length. And how do we do that? We have a right triangle. We know 2 of the side lengths, so let's use Pythagorean theorem. So by Pythagorean theorem, 1 squared plus the opposite side length squared is equal to 3 squared. In other words, we have 1 plus OPP squared is equal to 9. But again, we want the opposite side length, so we got to solve for it. So we can subtract 1, right? These cancel. And we have OPP squared is equal to 9 minus 1 is 8. Okay, but that's OPP squared. So the opposite side is the square root of 8. So the opposite side has length square root of 8. As above, our adjacent side, we took that to be 1. Hypotenuse, we took it to be 3. I'm writing all this down so that now we can get the trig functions, the other ones. So sine of theta, remember, that's opposite over hypotenuse. So that's going to be radical 8 over 3. Tangent of theta, right? Remember, that's opposite over adjacent. So that's radical 8 over 1, which of course is just radical 8. Okay, so we have these two. Secant of theta, right? That's 1 over cosine of theta. Cosine is 1 over 3. But again, 1 over a fraction means you flip it. So we have 3 over 1, which is the same thing as 3. Cosecant of theta, right? This is 1 over sine of theta, which of course here is 1 over radical 8 over 3, which is equal to 3 over radical 8. And finally, cotangent of theta, well, that's 1 over tangent, which is 1 over radical 8. Okay? So we have our 3. Let me just draw a line here to separate. So we have all our trig functions. We have radical 8 over 3 for sine. Cosine, remember, was given as 1 over 3. Tangent is radical 8, which is radical 8 over 1. Secant is 1 over 3, which is 3. Cosecant is 1 over sine, which is 1 over radical 8 over 3, which is 3 over radical 8. Cotangent is 1 over tangent, and here that's just 1 over radical 8. So that we could just leave alone because tangent of theta is just radical 8. So we have 1 over radical 8.